Now we're going to take a look at a third type of exponent problem. So it says simplify and find the value of 2 to the third power, then to the second power. So this one is different because I see two exponents. I see I have one exponent that's directly attached to the 2 as my base, and then I have another exponent that is outside of my parentheses. So let's think about what this problem actually means. So 2 to the third, we know, would be 2 times 2 times 2. Now, if I raise something to the second power, I take it and I multiply it by itself, which means I'm taking 2 to the third, 2 times 2 times 2, and I'm multiplying it by itself. 2 times 2 times 2. Again, anything that is raised to the exponent is multiplied by itself. So thinking about what we did with multiplying, I'm multiplying all of my exponents, or multiplying all of my 2's, and let's see how many I have to simplify. I have 1, 2, 3, 4, 5, 6. So to simplify this, this is going to be written as 2 to the 6th power. To find the value, I multiply out all of these 2's, and I get 64. So take a minute and think about, what do you see as the relationship or the connection between my original problem and my simplified answer? So when we raise a power to a power, so that means we have an exponent attached to the base is then raised to another power. That's called raising a power to a power. We are actually multiplying our exponents. So when we were multiplying with exponents, we added the exponents. When we were dividing with exponents, we subtracted the exponents. But now when we're raising a power to a power, or an exponent to another exponent, I need to multiply those exponents. So take a minute and pause and make sure you write this key point down for today. So for this basic problem, this is saying 7 squared is raised to the 5th power. So all I need to do is multiply to figure out what it is in simplest form, is multiply by exponents. So that is like 7, and I'm going to do 2 times 5. So this simplified out is 7 to the 10th power. Okay, take a moment and write this problem down. And we're going to combine what we did yesterday, right here, with today. So a couple of different things. Number one, I have like bases of 3. I see exponents in the parentheses, and I see that what's in the parentheses is being squared. It's being raised to the 2nd power. Thinking about order of operations, I want to see, can I take care of what is in the parentheses? Can I simplify what's in the parentheses? And I can. I am multiplying like bases. So thinking back, when I multiply with like bases, I'm going to add my exponents. So 3 to the 2nd times 3 to the 3rd is 3 to the 5th power. That means I would take 3 and multiply it 5 times. Now, I'm going to raise that to the 2nd power, what's outside of my parentheses. So like we just learned, when I'm raising a power to a power, I need to multiply. 5 times 2 is 10. So 3 to the 10th power is this expression in simplest form. Okay, looking at the second problem. Copy it down, pause if you need to. So here I see just like before, I'm raising a power to a power right here, and I see that I have division in my problem. So let's take care of the numerator. Let's simplify this. I can simplify this. So 4 to the 6th power, then raised to the 3rd power. I'm going to multiply my exponents. So this is going to be 4 to the 6 times 3 is 18. So 4 to the 18th power divided by 4 to the 5th power. Thinking about our last video, when I'm dividing with like bases, I keep my base and I subtract my exponents. So I need to do 18 minus 5, and that gives me 13. So my simplified expression is 4 to the 13th power. So now what happens when we raise a power, raising to a power, but with different bases? So this problem is different from the one we did before because inside my parentheses, my bases are 5 and 6. So if you remember back to one of the other videos, I can't combine these. These are not like bases. I can't just simply add my 2 and my 3 of my exponents. Okay, so I can't combine anything inside the parentheses. But I do see that I am raising exponents. I'm raising a power to another power. So everything in the parentheses is being raised to the 3rd power. So I'm still having to use that multiplication rule. We're basically distributing this 3rd power to each term inside the parentheses. Think of it like, again, distributing, except we're not distributing a whole to the whole number, we're distributing the exponents. So 5 to the 2nd, raise my 3rd power, I'm going to multiply my powers. 3 times 2 is 6, times 6 for my base, do the same thing, multiply my power, 3 times 3, and I get 9. And that's as simplified as it can go. Can't combine these are not like bases. 5 to the 6 times 6 to the 9. So key point, make sure you pause and write this down. If the bases are different, we had a 5 and a 6, we multiply the exponent outside the parentheses by each exponent on the inside. So I had to multiply my outside 3 by the 2, and then also multiply it by 3, and as always, we keep the bases. Okay, so now you're going to try a couple on your own. Simplify number 1. So number 1, power to a power, I'm going to multiply. 4 times 3 is 12, so simplified, this is 5/12 to the 12th power. Number 2. Same thing. Raising 8 squared to the 5th power means it's going to be 8 to the 10th power, and multiply my powers. Number 3. Okay, number 3, we've got a lot going on. Take it one step at a time, which means I need to simplify this numerator first. So I see that inside the parentheses, I do have like bases. So this goes back to one of our first problems. I can combine what is in the parentheses. I'm multiplying in the parentheses, so that means with like bases that I'm going to add my exponents. We're going to deal with the other one on the outside in a second. So this is going to become 2 to the 6th power, because 2 plus 4 is 6. And then that's raised to the 2nd power, right here, still on the outside, and we're still dividing it by 2 to the 7th power. Okay, can still simplify on the top. I'm raising a power to a power right here. So I need to multiply these two. 2 to the 6th raised to the 2nd power, 12, is going to be my exponent. 6 times 2 is 12. Still dividing that by 2 over 7, or 2 to the 7th power. And then lastly, since I am dividing with like bases, I'm going to keep my base, but I have to subtract my exponents. So 12 minus 7 is 5, make any corrections you need to. 2 to the 5th is the correct answer. And number 4. Okay, I cannot combine what's in the parentheses since we don't have like bases. So I just need to distribute this outside exponent of 3 to both the exponents inside. Since we're raising it to the 3rd power, I use multiplication. So it's going to be 3 to the 12th, because 3 times 4 is 12, times 5 to the 6th, because 3 times 2 is 6, and that's our simplified answer.